Hello, namaste to all of you. First of all, me Brajman Adhikari welcome you all of you in the English class. Today we have a very special lesson, English Grade 10 New Course NEB. We have Unit 5 today and the topic is Science and Experiment. Very interesting lesson. Yes, you can boil water at room temperature. Is the lesson. In the beginning of the lesson, I am showing you a picture. Students doing experiment in science lab. You all can see students are busy in the science lab and doing practical. After that, I am going to tell you about the lesson. Yes, you can boil water at room temperature is our lesson today. Sometimes it is right on the box of rice mix. The high altitude version of cooking instructions. Usually this means that your rice will have to cook a little bit longer if you are in Denver or at the top of Mount Everest. Of course, that is just a joke. No one cooks rice at the top of Everest. But why are the instructions even different? Why does it matter where you cook? The answer has to do with boiling water. Go ask some people on the street about the boiling temperature of the water. Some might say 212 degrees Fahrenheit or even better 100 degrees Celsius. But that's not always true. As you increase your altitude above sea level, the boiling point of water decreases by about 1 degree Fahrenheit for every 500 feet increases. That means your water in Denver is going to be 203 degree Fahrenheit and this will have an impact on your cooking. But why? There may be questions in our mind. Again here I am going to present a picture for you. A lady is just doing practical. She is checking water vapor pressure in the laboratory. She is busy in checking. After looking the picture, let's move ahead. Water vapor pressure. There are many awesome things about water. One interesting factoid is that on the surface of the earth, you can find water in all three phases. Solid, we call this ice, liquid water, and a gas. We call the gas phase of water water vapor. You might think that you need to boil liquid water to create water vapor, but you don't. You just need some liquid water at room temperature or any temperature. Picture a glass of water. If you could zoom in with supervision, not actually possible, you would see that this water is made of a bunch of molecules, that is, water molecules. Although these molecules are themselves made of three atoms, two hydrogens and one oxygen. Let's just think of them as teeny balls. Now again, I am showing you a picture. Water vapor pressure. After checking this picture, let's continue our lesson. These teeny water balls are moving around in the water but stay fairly close to their ball neighbors. This motion isn't due to currents in the water. Instead, this is thermal motion. Imagine these teeny balls jiggling around in a giant collection of balls. The hotter the water, the greater the motion of these water balls. But wait, the speeds of the water particles aren't all the same. Although there is an average ball speed, some are going faster and some are going slower. It is just like the height of a group of adult humans. There is an average height, but everyone is not the same. Some people are very tall, but that is just a small fraction of the total group. In this way, if you have a glass of water sitting out on a table, the water balls don't just stay as a liquid. Some of these balls have enough thermal energy to break away and become free. Free from the liquid stage means the water ball is now a gas, that is water vapor. Boiling is not needed to get this water vapor. But wait, it works the other way too. Some of the water balls in the gas stage can interact with the liquid water and join the liquid water balls. Water in a closed container, like a water bottle, will eventually reach an equilibrium state between water vapor and liquid water. At this equilibrium state, the rate that water balls are freed from the liquid state are the same as the rate of water balls entering the liquid state. The pressure of this water gas in equilibrium is called the vapor pressure, assuming it is all water gas and no air in the container. Now, through the picture, you all can understand vapor pressure. In the first container, first it means picture evaporation. In the picture number B, second picture, rate of evaporation is greater than rate of condensation. Now in the picture number C, evaporation is equal to condensation. This is the simplest explanation, and I think everyone will understand it in an easy way. You can see evidence of this water vapor in a closed container by looking at the water that condensates on the walls. Here is a picture. As you increase the temperature of the water, there are more and more water particles that have enough energy to leave the water phase and becomes water vapor. So the water vapor pressure will increase with the temperature of the water. This is very important. Now boiling water. Now for boiling water, here is what water looks like when you get it to 100 degrees Celsius in slow motions. Yes, I know you have seen this before, but it is still cool. Look at the bubbles and answer the following question. This one is a classic. What are the bubbles in the boiling water made of? Ask your friends, ask your enemies, ask yourself. Are the bubbles made of air? What about some hydrogen and some oxygen? No. The bubbles are water vapor. They are small pockets of water in the gas phase. I mean, they couldn't be air. Where would this air comes from? The only option is that the bubbles are made of water vapor. So, what is happening to make these boiling bubbles of water vapor? It is all about temperature and vapor pressure. As the temperature of the water increases, The average speed of the water particles also increases. At some point, water molecules have enough energy to push back other water molecules in the liquid phase to form a bubble. But you have to have the water hot enough so that the particles are moving fast enough. Again, here we have a picture. The water is boiling here, and from the down here, the burner is burning, and in the it means pot, the water is boiling. You can see the particles are boiling. Now let's continue. But wait, it is also about the vapor pressure. In order to keep the bubble from collapsing, the pressure inside the bubble must be equal to the pressure outside the bubble. Inside the bubble is the vapor pressure and the outside is the water pressure. This means that for water to boil, the temperature must increase until the vapor pressure is equal to the outside pressure and a bubble can form. What about that external pressure? That depends on two things. First, the water itself. In order for the water to not collapse, the deeper water must have a higher pressure. So the water pressure depends on the depth, the density of water, and the gravitational field, since it is due to the weight of the water. For a typical glass of water, the pressure at 2 centimeters below the surface is only a 0.2% increase over the atmospheric pressure. And that is the second thing that contributes to the total pressure, the atmosphere. The atmosphere also pushes down on the surface of the liquid to increase the pressure in the liquid. Now let's see again boiling water from the down, the burner is burning and the water is boiling in the pot. Now let's talk about low pressure, lower pressure. Now for the fun part, what if I decrease the atmospheric pressure pushing on some liquid water? This would reduce the pressure in the liquid also. If I reduce this pressure enough, I can bring it down to the same level as the vapor pressure. Boom! Now the water particles have enough energy to form their teeny little boiling bubbles without the need to increase the temperature. I can even get water to boil at room temperature. Yes, you need a vacuum pump and a strong container to get this to work, but you can do it. Notice that I hold on to the boiling water flask just to prove that it is not hot. Trust me. Oh, wait. You don't have to trust me. You can do this on your own. You just need one of these large plastic syringes. Get the syringe and put some water in it with very little air. Now seal up the end and heat up the water just a little bit. Here you can see many versions. I used hot glue and a rubber stopper along with a LEGO piece to seal the hole. The syringe was then heated to about 42 degrees centigrade, a little over 100 degrees Fahrenheit. Now I can pull the plunger out to decrease the pressure in the liquid and induce boiling. It is pretty tough to pull the plunger back to decrease the pressure, but you can do it. Oh, what? Why heat the water up? Well, I can't get a perfect vacuum by pulling the plunger, so I need a little boiling help by starting the water at a higher temperature. This is exactly what is going on when you cook your rice at a high altitude. Well, not exactly the same. There is not a human cooling bag on a giant plunger that holds the air on Earth. The Earth's gravitational field does that for you. Here you can see liquid pressure. It means down there is more pressure. The water is, it means, flowing farther than the top. You can see there is low pressure at the top and just falling very near. So from this practical also, we can understand there is more pressure at down and at altitude there is low pressure. After examining the, it means, picture, again come to this point, we have another picture, atmospheric pressure and boiling. Just examine this picture for a few seconds. After that we will continue. Okay, thank you. Now let's continue. Glossary of the text. Some of the important words are there and which will be tough for you. And I'm going to explain those uh, important words. First is altitude. With the pronunciation is there. The height above the sea level is called altitude. Another one is atmosphere. Atmosphere, the layer of gases surrounding a planet. Boiling, boiling, the process of liquid turning into vapor by the action of heat. Bubbles, small spheres of gas or air trapped in a liquid or solid. Condensates, changes from a gas or vapor to a liquid state. Container, a receptacle used to hold or store something. Decrease, to become or make less in size, quantity or intensity. Depth, the distance from the top surface to the bottom of something. Equilibrium, a state of balance between opposing force or actions. Evidence, facts or information indicating whether a belief or proposition is true or valid. Now after this we have the more words. Flask, a narrow-necked container used to hold or carry liquids. Gravitational, relating to or resulting from gravity or gravitation. Higher, situated above another position or object. Hot, having a high temperature. Hydrogen, a chemical element with the symbol H and atomic number 1. Impact, the effect or influence of one thing on another. Increase, to become or make greater in size, quantity or intensity. Induce, to bring about or give rise to. Instructions, detailed information about how to do or use something. Jiggling, moving with small, quick and irregular motions. Liquid, a substance that flows freely but is of constant volume. After checking this, we have more vocabularies. Molecules, the smallest unit of a chemical compound. Particles, a minute portion of matter. Phase. Phase are distinct states in a process of change or development. Plunger, a movable device that is pressed or pushed down. Pressure, the force exerted per unit area. Proof, evidence or argument establishing a fact or the truth of a statement. Pumping, the action or process of moving liquid or gas by means of a pump. Reduce, to make smaller or less in amount, degree or size. Room temperature, the normal temperature of a room, typically around 20 to 25 degrees centigrade, 68 to 77 degree Fahrenheit. Seal, seal, to close or fasten securely. Surface, surface, the outside part of uppermost layer of something. Now more vocabulary. Temperature, the degree or intensity of heat present in a substance or object. Thermal, thermal, relating to heat or temperature. Teeny, extremely small in size. Total, the whole amount or number. Vacuum, vacuum, a space entirely devoid of matter. Vapor, a substance diffused or suspended in the air, especially one normally liquid or solid. Version, a particular form of or variant of something. Water, a colorless, transparent, odorless liquid that forms the seas, lakes, rivers, and rain. Weight, the force exerted on the mass of an object due to gravity. Work, activity involving mental or physical effort done to achieve a purpose. Zoom, to move or travel quickly. Now we have exercise. Find the words from the text that have the following meanings. The height of an object or point in relation to sea level or ground level, that is altitude. A group of atoms bonded together, that is molecule. A state in which opposing forces are balanced, that is equilibrium. To change from a gas or vapor to a liquid, condense. A piece of unreliable information that is repeated so often that it is accepted as the fact, that is factored. A space or container from which the air has been removed, that is called vacuum. A device that is used to remove blockages from the drain of a basin or tube, that is plunger. Plunger. Now, exercise B. Complete the sentences with the correct words or phrases from the text. Water bubbles break down if vapor, and we have the blanks, and we can feel pressure inside and outside the bubbles is equal. As the altitude goes up, the boiling point of water decreases. Random motion of molecules or particles is called thermal motion. All it means blue color is answered. If the door does not open, try jiggling the key in the lock. Here jiggling is the fit word for the blank. Certain chemicals can induce undesirable changes in the nervous system. Induce is the right a word for the blank space. Now answer the following questions. The questions are related with the text. It means our lesson. What is the speed of the water particles compared with? The speed of water particles is compared with the temperature of the water. How are bubbles formed in the boiling water? Bubbles are formed in the boiling water due to the vaporization of water particles that become trapped in small pockets of air. Mention two things one on which external pressure depends. External pressure depends on the mass of the atmosphere and depth, density, and the gravitational field. How is the atmosphere related to the pressure of water? The atmospheric pressure affects the pressure of water by applying a force on the surface of the water. What would happen if the atmospheric pressure on the liquid water was decreased? If the atmospheric pressure on the liquid water was decreased, the boiling point of water would decrease, causing it to boil at a lower temperature. More questions we have. What would the experimenter gain if she or he pulled the plunger out? If the experimenter pulled the plunger out, it would create a vacuum in the container, causing the water to boil at a lower temperature due to the decrease in pressure. Next question. What would happen on the earth if there were no gravity? Discuss possibilities with your friends. If there were no gravity on earth, everything that is currently held down by gravity would float up into space. This would include all living things, buildings, vehicles, and even the oceans. The earth would essentially be a massive floating ball of matter in space with nothing holding it together. The lack of gravity would have a significant impact on the human body. Without gravity, bones and muscles would not need to work as hard to support the body's weight, leading to loss of bone density and muscle atrophy. In addition, blood would not be able to flow properly without gravity, which could lead to cardiovascular problems. Now, further, we have the lack of gravity would also affect the Earth's atmosphere. Without gravity to hold it in space, the atmosphere would gradually escape into space. This would make it impossible for humans and other living things to survive without artificial means of generating air and other resources. Finally, without gravity, the Earth's orbit around the Sun would be affected, potentially leading to a catastrophic collision with another planet or celestial body. If there were no gravity on Earth, the consequences would be severe and wide ranging. The lack of gravity would affect all aspects of life on Earth, from human health to the environment and beyond. Match the clauses with their appropriate continuation. If you go to Taplejung is matched with the third number, you can see the Pathivara temple. You will get well soon is matched with number 1 if you follow the doctor's advice. The horse won't kick you is matched with number 2 unless you go behind it. If I were you is matched with number 6, I would see a doctor. What happens is matched with number 4 if you hit water. I would miss the bus is matched with number 5 if I did not reach the bus stop on time. Provided that they discussed properly is matched with number 7, they won't have misunderstanding. As long as they communicate well is matched with number 8, the problem might be solved. After this, we are going to move ahead. Complete the following sentences using the correct form of verbs in brackets. If it is cold, I, gap is there, and inside the bracket wear a coat. If it is cold, I will wear a coat. For the number second, the answer is if Purna helps with the housework, his mother will have more time for him. So will have is the right answer. For number C, if I were a bird, I would make a good observation of the land below. Here we have used would make. If I went to Mustang, I would visit Muktinath. Here go change into went here. If I were a billionaire, I would buy a castle. For B verb, we have used here where is the right answer. Now after this, we are going to move ahead. Another is you would save petrol if you drove more carefully. Here for drive, we have used drove, verb to form. Say hello if you see her. Same verb we have repeated here, verb 1. Provided that you consent, I will take a few days leave next week. Here we have used consent is repeated there, not change. Take care of the pens, the pounds will take care of themselves. So will take we have used. Now writing is here. Write a stepwise instruction to draw a jellyfish as given below. You may use the following words and phrases. Words and phrases are circle, lines, semi-straight, creaky, on top of, above, below. How to draw a jellyfish? Instructions are here. So first instruction is given for you. Begin by drawing a circle for the jellyfish head. Second instruction is draw a line extending downwards from the bottom of the circle for the jellyfish body. Next instruction. Next, draw several semi-straight lines extending downwards from the body. These lines will represent the jellyfish tentacles. Now, another instruction is add some creaky curves to the tentacles to make them look more natural. Another instruction is on top of the jellyfish head, draw two large circular eyes with small dots in the center for pupils. Next instruction for you is draw a small smile below the eyes to give the jellyfish a friendly expression. Now we have finally add some shading or color to your drawing to make it stand out. Consider adding some light blue above the jellyfish and darker blue below to give the impression of water. Congratulations, you have successfully drawn a jellyfish. In this we have completed our lesson for today. Thank you for watching this long video, informative video, which will be very beneficial for the grade 10 students across the Nepal. And those who want to get some idea, for them there is no boundary, anybody can check it. Even the it means instructor who is teaching this subject may get some benefits from this. And finally, I request you all subscribe my channel, like, share and comment for my channel so that I can make further it means lessons I will bring for you. At least now I will try my best to bring at least one it means lesson for you. Thank you very much for watching this. May God bless you. Have a nice day.